Okay, you'll recall that I left you Theorem 2.5 to finish at home, and so I'm just going to give you the filled-in slide for that theorem now. So what the theorem is saying is that if you have this biconditional statement, P if and only if Q, this is logically equivalent to P implies Q and Q implies P both being true. Now you'll remember when we talked about the converse of a conditional statement like this one. So we had P implies Q might have been true, and we said that it's not necessarily true that its converse, Q implies P, is also true. Sometimes it is, and when they're both true, then we have this biconditional statement. So how are we going to prove that these two statements are logically equivalent? Well, we're going to do it by a truth table, and what I've done for you already is I've filled in the P's and Q's like I normally do in the same order. And you'll recall from the definition of P if and only if Q that it was true when both P and Q were true, and it was true when both P and Q were false. Otherwise, the truth table gave us false values for P if and only if Q. On the other hand, P implies Q was true when P and Q were both true. It was true whenever P was false, but it was false when P was true and Q was false. Going the other way, Q implies P. It's true when P and Q are both true. It's true when Q is false. And it's false when Q is true and P is false. So we've got the conditionals filled in here and the biconditional. Now we're just thinking about these two columns, and what we're going to fill in here is when P implies Q is true and Q implies P is true. So we're looking for places where both of those things are true. So it's certainly the case in the first row that both of those things are true, and it's certainly the case in the last row that they're both true. But in the second and third row, only one of them is true, the other is false. So I'm returning a false value there. Okay, well, what do I need to show these two statements are logically equivalent? Well, I need to show that the columns in the truth table are the same. So I'm looking at those two columns. So in the first row, they're both true. In the second and third rows, they're both false. And in the fourth row, they're both true. So that shows the logical equivalence of the biconditional with P implies Q and Q implies P.